I am very honored to be with Jim Gosselin, owner and president of Genevieve Swiss. Welcome to the show, Jim.
Thank you, Noah.
This is great. I've known of Genevieve Swiss a while, and Mark Klecka, previous guest, said, "Oh, you totally need to interview Jim." So, um, I am excited to learn all about what he has to say about Swiss machines. So just to start, I want to get just a brief overview of what Genevieve Swiss sells, and then I'm going to get a little about you, and then we'll go into some topics. But just to get people started,
I'll
what
give
do you
you
guys do? What are you all about?
I'll give you our headline. It's tools and accessories that advance small parts manufacturing. And I believe our part of our mission is making the job of the machinist easier so that their day goes by a little bit better. Companies become a little bit more profitable and with better efficiency, quicker setups. Um, so that's what we're here for.
Awesome, perfect. And now I want to get the 3-minute life story of how you got to where you are today, and to go into uh, also some more history of the company. Um, so you started out young person, assuming you were interested in mechanical stuff early on.
Oh, I've always been interested in mechanical stuff. As a kid, I'd take apart my toys. Didn't necessarily get them back together the right way, but it was kind of a hobby trying to figure out how things work.
Mm-hmm. And and then uh, did you go to regular college, or what did you study?
Well, I actually quit high school. I went into the service for to be a combat engineer, basically build things and blow things up.
How old
And
were you when you
when I
quit
got
high
out,
school? You quit high school?
I quit high school.
Well, kids, this is a good lesson. This is where dropping out can lead. What grade were you in?
I was a junior, so my third year in high school.
So you didn't fit into the mold
It
of.
was the 70s. What can I say?
Okay, so um you got into the military, and then what?
When I got out, I needed a job. Eventually, I wound up working at a company called Savage Arms in Westfield, Mass. They make rifles and shotguns, sporting equipment.
Mm-hmm.
And after a couple of years there was an opportunity to become a programmer for new CNC machines that were coming in. And by the way, I did go back to school. I finished with getting a GED and started taking college courses at night.
Okay. And so you were operating um at the first company. Were you operating just CNC lathes, or were they not even CNC back then?
They
This was the
were
80s.
in 1983, to be exact. They had bought 10 Citizen machines and 5 Karaki machining centers, and I was responsible for the Citizen area.
I didn't even know they had Citizen machines, CNC machines back in 1983.
Yeah, they were state of the art back then. 2 turrets with 5 stations each, uh, cross drilling and milling capability. And back then it was actually a sliding guide bushing, not a sliding headstock, at least on those types of machines. So I'm really dating myself.
That's why it
And
was using turrets.
Yeah, the turret and the guide bushing slid together.
Wow, interesting. Um, okay, so you worked there, then you became a programmer.
I
Uh,
did uh, I did the programming, laid out the processes, did the maintenance on the machines. Whenever something went wrong, I was the guy to get in and take care of it. And I stayed there for several years
mhm.
and left for an opportunity to become an applications engineer and salesperson with a company called Brookdale Associates back in 1987.
And they were distributing Citizens?
They were distributing Citizen machines in New England.
Interesting, 1987. So, okay, so you did that, and you did that a while, right? Like 15 years? Or
Yeah, I was doing that for 15 years. I left the company in 2002 to start Gen Swiss.
okay. So, give me the story of how you decided to do Gen Swiss. You went to Switzerland and made some contacts there. Is that the something like that?
Yeah, back in the late 80s, we had gotten involved in high pressure coolant systems, building our own high pressure coolant pumps for the machines. And that's when high pressure coolant on a Swiss type machine really wasn't heard of. It was kind of something that we had gotten going, and we were using it for not just drilling, but for turning, for grooving, for cutoff operations, for milling, every process in the machine. We also had a line of accessories that tool holders and different things that we were coming up with to enhance the machine capability. So we
Mm,
made a trip over to Europe. I think we visited 5 countries and made contact in Switzerland with a company that sold live tooling. And they had some beautiful tools. They were state of the art, very attractive, very high precision. And the company reached out to me to offer selling the tools. So
mm,
at that time, I had put together a business plan for my boss, figuring that Brookdale would sell these. And this was in 2002. And he said, Jim, it's a bad year. He says, if you want to start your own company, I'll back you 100% and I'll be your best customer. And so
interesting.
that's what I did.
And yeah, so 2002, is that was a tough time for the machining industry?
That was the year that if you went to IMTS, you could use it as a bowling alley because there was nothing in the way. The aisles were empty.
Worse than 2008? Or
Yeah, worse than 2008.
okay, so you started this company, and it evolved from just selling tooling to becoming a company to make people run their CNC Swiss machines better. Is that a good way of summarizing it?
Yeah, and what I recognized then, and I think it's still true today, is the very experienced operators, setup guys, programmers, there weren't a lot. And the ones that were around were already getting older. So the people with experience were getting kind of burnt out.
Hmm.
They were doing everything from programming to training to setting up the machines to being the guy that fixed the problems that came up every day. And I kind of looked at it as my mission to try to make their job a little easier, come up with products that could make the setups easier, come up with products that could make the cycle more efficient.
So you're saying products to make it easier for the new guys coming in?
right?
Yeah,
And for the old guys, so that their job was a little bit easier.
interesting. So you developed um, live tools with gear-driven technology, you were telling me before. Can you explain what
Well,
sort of development that was?
yeah, what I did was I worked with a company called PCM, which is where we get our live tooling from. It's a Swiss company. And at the time, there really weren't a lot of speeders for the CNC machine, the Swiss CNC machines. And, you know, it was, I think, 4 to 5,000 RPM for cross drilling or cross milling.
Mm-hmm.
Now, that's not bad, but when you're dealing with an end mill that might only be 20 or 30 thousandths in diameter, 5,000 RPM just doesn't quite cut it.
Okay.
You have slow cycles, you get burrs. It's just not efficient. And I worked with PCM to develop a gear-driven head that would give you 3 times the output.
Wow, 3 times the output. And you were you and PCM, you guys were the first.
We were the first that I'm aware of,
Mm-hmm.
and it remained that way for several years.
Were you able to
Uh,
patent that?
no, we didn't patent that. No.
Okay, so what are all the different things that Gen Swiss sells?
We sell live tooling. We sell cutting tools for Swiss, specifically for Swiss type machines. We don't really do anything for big lathes or milling machines. It's all geared around Swiss type and small part manufacturing. We sell accessories like arbors for slitting, very high precision. We sell coolant specifically designed for high pressure coolant delivery. Um, some of the products that we have, uh, here's
Oh,
one here,
oh, great.
live tooling. This is a thread whirling head
Wow.
that with this thread whirling head, PCM developed it to have coolant that comes right through the head and delivers right to the cutters. And this is
Yeah, be very descriptive for the people that are not watching this.
a cutter ring here. So the coolant would actually come right in between the cutters. And this is a fairly new head that they've developed. It has a quick change ring on it as well.
Okay.
So it just slips in, quarter turn, locks in. And it's a really nice tool that they've developed.
Yeah, it looks pretty heavy duty.
Yep.
So what you'd put that on any
This
kind of Swiss
actually goes
machine?
on to, I believe, an L20
Okay.
Citizen machine. Yeah.
What would a thread whirling tool would it go, could you take that from a Citizen to a Star, like, or would you have to get a certain adapter or?
No, you would have, generally, you would have a live tool that's made for that specific model of machine.
Okay.
PCM did develop what they called modular tooling. These are small tools that a thread whirling head could have a changeable adapter and go from a Citizen to a Star to a Sagami potentially.
Interesting. Interesting. All right. Well, let's talk about the stuff you see a lot of uh, machinists, setup people, people operating Swiss deal with. What are the biggest hurdles that people call you with and that they're trying to solve to keep their machines going and to get the most out of the machines. Chips is a big deal, correct?
Chips is a really big deal. The With the medical industry and materials like 465 stainless, chip control is a big problem.
Mm-hmm.
15.5 pH. These are very gummy materials. They chips come off like ribbons. And one of the things that we're working with our insert tooling company called Utilities is laser ground chip breakers. I don't know if you can see this or not, but I'll try to show it. This has
Interesting.
a,
Wow, that's small.
yeah, it's small. This has a chip breaker right along the edge that's really tuned for medical grade materials. And this has, this was some 465 stainless steel that we took about 100,000 depth of cut in 465. And that's the kind of chip that we're getting with that chip breaker that's on here.
Wow, that's so tiny.
Before this, they were just ribbons. I mean, chips were everywhere in the machine. It was very difficult to control, even with high pressure coolant.
Right. So your main weapons for dealing with chips would be something like that, and then maybe the low frequency vibration feature on
Yeah,
a Citizen.
LFV is something that the machine tool companies offer. It's not something that we can provide,
Yeah.
but it's certainly a recognized force that is really helping to solve chip problems.
Mm-hmm. And then high pressure coolant,
High
obviously
pressure
too.
coolant is really it's become such a powerful tool that I think probably more than 90% of Swiss type machines sold in this country have high pressure coolant systems on them.
Really,
Yeah.
I haven't necessarily noticed that uh,
Uh,
with some of the used ones, but it's possible that people are just pocketing the high pressure coolant pumps and not wanting to sell them with the machine. Um, and some of the machines I've looked at some machines in Asia, and a lot of them didn't have high pressure coolant. What kind of parts do you not need high pressure coolant on? Just stuff that doesn't produce bad chips, material that doesn't.
Right. Brass, cold roll steels. Um, but as soon as you start getting into stainless steels, titaniums, alloy steels, like for even 4140, high pressure coolant really becomes the tool of choice. It's kind of like taking a sledgehammer at that chip and you're just blasting it with force. And somebody's described it to me once as blowing leaves off of your driveway.
Interesting. And so you guys sell the high pressure coolant pumps.
We do not. We
They
sell,
just come with the machine.
right, they're coming with the machine. What we do is we're selling the tools that allow the coolant to get right down to the chip. High pressure coolant is a wonderful thing, but if you can't get it right to that tool tip, it's a problem. I bought my first machine about 10 years ago, and it had on a standard manifold that came with the high pressure coolant system, and it was using brake tubing.
You bought your first machine?
Yes,
You had never actually bought a Swiss machine yourself, you're saying?
right. Now we're manufacturing in-house. So I bought the first one about 10 years ago.
What did you buy? A Citizen? Because you knew
It was a
Citizens?
Citizen because that's what I knew.
Mm-hmm.
And
Okay.
the brake tubing was an absolute pain in the butt to try to get it focused at the chip or right at the tool tip.
Mm-hmm.
They were hard to bend. You'd have to use nozzles that would um, focus the jet of coolant. A lot of times you drill and tap the end of it, and then you'd end up breaking the tubing off. You bend it too many times, the tubing would break. So now you'd have to reset it back up again.
Mm-hmm.
And we started working with utilities, developing through the tool coolant. So this is
Nobody was doing through the tool coolant before that?
very few companies were. There might have been one or two, but this is a tool. It's a little bit difficult to see, but there's a hole right there,
Mm-hmm.
and it's focused directly down at the tool tip.
Ah,
And
interesting.
coolant comes in either from the side or from the back, either one. So depending on the machine configuration, this is a little bit, it's adaptable for different kinds of machines. It can be used in a Star, Citizen, Tsugami, Hanhai.
What about just a single spindle lathe?
Absolutely.
Yeah.
Can be used for a single spindle lathe. But this did such a much better job delivering that coolant where I needed it. And it saved me a lot of time that I didn't have to go screwing around with brake tubing.
Interesting. Yeah, I could see how those things would be a pain.
Yeah, then utilities developed this. And this is
There's going to be a lot of cool, interesting little videos, everybody. So you'll have to tune in to Today's Machining World, or log on rather than tune in. And
so this is actually a coolant wedge. This is what holds the tool into the gang plate. Coolant is delivered through here or here, and it comes right out at the very tip of this wedge. And your tool holder can butt up against the stop, and it's delivering that coolant right down to that tool tip.
interesting.
So what this does is you're delivering it through the wedge. You don't have any hoses connected directly to your tool. So to change your insert out or take your holder out, you just loosen the wedge, pull the tool out, put your new tool back in. Everything's where it needs to be.
And what percentage of companies are using some of these innovations?
I'm not sure what percentage, but I know we've sold a lot of them.
Mm-hmm. I'm sure. Um, Anything other specific challenges? Just some big troubleshooting things. I mean, it seems to me, and this goes along with all the stuff you're saying, it's just you you don't clean your machines, and all the crud gets in there, and doesn't matter, even eventually if you have the high pressure coolant, you're just blowing crud, swarf on swarf. um
Yeah.
Anything else you guys specifically sell that um people say, oh my god, Jim, you changed our life in our shop?
Uh, Probably our Tylock product. This is it's an end mill extension. See if I can show it here.
Yeah, you can see it. Yeah.
Yep. You see the end mill. That end mill's probably only about 20 thousandths in diameter. And it sticks out roughly 1/4 of an inch. Now, with the Swiss type machines, there's a point where your gang slide comes down to, and then you stick your tool out. And this is generally about the length that your tool would be sticking out past the collet. So if you could imagine this little guy here sticking out of your collet like that,
Mm-hmm.
you lose all kinds of rigidity. It just starts moving around and flexing on you. You can't help it. But what we've done is we've integrated a more rigid neck onto the ER collet taper. It's a one-piece design, and it allows you to take up that space with the extension and just stick the end mill out only the amount that you need.
Very interesting. How much of this stuff do you engineer yourself, or do you just have a big team and you're kind of the visionary?
Um, in this, we're a small company. Um, there's 19 people here. I'm the one that designed this product, and it was only out of need. I needed to get around a sub spindle. I had a small tool. The sub spindle was, 2.5-inch diameter nut, and I had a really small part to get down to. I needed an extension.
So a lot of your innovation now is a product of you actually owning the machine. So it's a lot easier for you to come up with important products since you bought the machine.
Right.
So
That's where
did you go, why didn't we buy this machine like ages ago? So then you could.
That's where I found most innovations come from the shop floor.
So are you constantly asking your customers for feedback and saying, all right, what are you having trouble with? Come at me. And
absolutely.
Mm-hmm.
Absolutely. The problems in the shop, they don't go away. Once you've solved one problem, there's another job that comes in the door that is going to present a new problem. And
how do you invite that feedback from people? Do you have like message boards? Do you have you constantly calling people and saying, is everything okay with your machines?
It's really interacting with the customer and or the distributors that where we're walking into a shop and customers complaining that, hey, I've got a chip problem with this particular job, or I've got a coolant delivery issue. In some cases, it's just noticing the things that they're using and having had experience with problems that you recognize and asking the customer, geez, are you having a problem with that manifold that you're using? Mm-hmm. Is it a pain in the ass to set up?
Yeah, no, I mean, I think it reminds me of some of the other people we've interviewed where they said one of their secrets was just their customers coming to them, and that's how they knew what to do and what to give them. But now you have the added benefit of you having your own machine and you're going, oh, I'm dealing with this. And is usually has one thing been more successful than the other? The product problems you've encountered or the problems that people have contacted you about?
Not really sure I understand your question.
Well, so you've come up with products based on stuff that you've encountered running your own machine, and you've also come up with products based on stuff that people contacted you about that they're dealing with at their shop. So one is kind of like I'm thinking of like Steve Jobs. He would come up with ideas and say, everybody ought to do this, as opposed to, oh, people are asking for this.
It's a mix. I think most of the things that we're delivering, someone has probably done before, but it was either you had to make it yourself, or it was a very difficult thing to find. An example of that is
interesting.
This right here. This is we call it a dogleg tool. It's been around for a long time. There's a center drill in one position and a drill in the other position. And this is when you've run out of ID positions on your machine. Some of the older machines might only have 3 or 4 ID tools. This would allow you to put into a turning position a drill.
Mm-hmm.
So you've got, a machine like an old Citizen L16 that had 3 positions. This just gave me 2 more positions to be able to make a part. Now, I didn't come up with this design, but it's been around for a long time, but they're hard to find. There's a few companies that have it.
Mm-hmm.
This just happens to be one that we produce.
Brilliant.
This is another product that we have for knurling. Knurling on a machine is very difficult. There's a lot of pressure when you bump knurling.
Okay.
And what we came up with was a straddle knurl that allowed you to run your material in between the 2 wheels. So the forces are into the wheels and into the holder rather than pushing against the product, against your material.
Yeah.
And forcing that material away. This is
the material is being pushed into that, you're saying.
Right. It's being pushed through that. And this is an adjustable holder. So happens to be one for 3/8, but we go up to 5/8. And it's another product that we sell. And we've sold a lot of these also to help customers.
I'm not sure. Maybe this is a dumb question. I mean, I'm coming from the screw machine world. Would you have a tool similar to that for thread rolling, for threading it, or just that's not how you would do it on a Swiss?
Right. That's not normally how you do it on a Swiss. Thread rolling on a Swiss, you'd probably use like a Fetty die head, which
Okay.
is a 3 dies. The old Brown and Sharps, I remember, had reed rollers where you'd come in from the side like that.
Sure. Well, no, I mean, I'm used to, cam multi-spindles. They have.
Yeah.
Right. So that was what you got me thinking of when I thought of the knurls, the knurling. So you said before, I was saying, when we were talking our other conversation, somebody told me that machines today, they're just not built like they were, say, 25 years ago. The castings aren't as rigid. And you suggested that despite that, they're more cleverly engineered. You want to just talk about that for a second?
Yeah, we have, the older machines were designed with weight, not so much, to get their rigidity, they built a very heavy machine. So the more metal around it, the more rigid it was going to be. And today, machines are built more intelligently. So where you don't need casting, they're using, CAD programs and solid modeling, and they're doing, stress analysis on their castings and on the headstocks, on the everything, that goes into the building of a machine. So I think the machines don't need to be as heavy, and they can still deliver the rigidity.
Interesting. Just a few other questions. One thing, I'm always wondering about the future. Where do you see Swiss machining? Where do you see the innovations of these machines, say in 10 years? Can you look down the line and you say, oh, well, what if they could do this? Maybe they'll develop it.
Well, some of the emerging technology right now is lasers on a Swiss type machine. And that's pretty cool when you consider you can be doing, laser cutting, milling,
So
drew
you're
cross
talking about like I
turning.
saw on the Citizen at the show where the part came off, and well, before the part came off, they lasered it to make more more threads in the part, or like for a bone screw, or is that what you're talking about?
Yeah, I think these are being used a lot in the medical industry for
Yeah.
endoscopy, and you know, but for a lot of different things they can be used for. But just that technology of lasers on a machine, that's pretty cool. I mean, thinking of that you could actually make two parts and then weld them together on the machine.
Wow.
Yeah, that's pretty incredible. Um, where could it go from here? Well, 3D printing is certainly
Right. Is it, are
in.
people are any of the builders concerned that 3D printers may creep up on them and take away some of their business?
I'm sure it's a concern at some point. Right now, 3D printing is slow, but it's only taken a few years to go from only being able to print plastic to now
Mm-hmm.
they're printing titanium parts. Um, so maybe in the future, we'll have 3D printing Swiss machines. Who knows?
Yeah, that'd be awesome. So, I mean, I can't really imagine it, but I mean, the lasers, that is interesting. You're the one of the people that has talked to me the most about that. Um, what's something you learned last week?
Uh, I never know everything,
Okay. Well,
but
was
always,
there something specific that made you realize that?
yeah, talk to my wife.
All right. Um, well, I really appreciate the interview. This was so interesting. It's so nice when people bring all the products and we can try to paint a picture of it, and it's not so abstract, although it might be abstract for people just listening. So this is extra incentive to check out the videos. And is there anything else you'd like to say to the people of the world?
um, keep moving forward, make a difference.
Awesome. Well, I appreciate it. And if anybody wants to check out Genevieve Swiss, you can check out their website online. It's genswiss.com. What's the URL?
Yep, genswiss.com.